This could be the beginning of something truly unsettling. Astronomers have made a shocking discovery on a distant exoplanet. Light emissions are being detected from the planet's dark side, something that simply shouldn't be possible. The data, collected by one of the most advanced space telescopes ever launched, reveals a mysterious glow, one that appears oddly artificial. Could this be the first real evidence of life beyond Earth? Or perhaps something even more enigmatic? While scientists are proceeding with caution, behind the scenes, some are already discussing the possibility of an authentic alien signal. These strange light emissions from the night side of Proxima B have drawn intense interest from astronomers across the globe. Initially spotted by ground-based observatories, the signals were later confirmed and studied in detail using the James Webb Space Telescope. What's most compelling, these emissions consistently appear in specific infrared and visible wavelengths, repeating with a frequency that suggests a persistent, and possibly technological, source. What does it mean that we're now picking up a signal from the side of the planet that is permanently shrouded in darkness, forever turned away from its star? In this region, where starlight never reaches, reflections can't be the source. So if the light isn't coming from the star, what is it? The signals we've detected show periodic fluctuations in intensity that don't match any known natural astrophysical phenomena. This leaves us with two possibilities: either we're witnessing a completely new kind of cosmic event, or the source is artificial, possibly pointing to intelligent life in the shadowed regions of Proxima B. The thought of life thriving in total darkness, perhaps even generating artificial light or advanced technology, stirs something primal in us. Culturally, we've often associated creatures of the dark with fear and the unknown. Of course, there are more grounded explanations too. The signal might stem from thermal irregularities, such as volcanic activity or atmospheric gases producing unexpected emissions. One possibility is that energetic particles from Proxima B's parent star ionize the planet's atmosphere, with some of these particles potentially reaching the night side via magnetic field leakage currents. Another explanation could be airglow, a natural phenomenon where atmospheric gases emit light. However, no distinct spectral lines have been detected in the data so far, making this scenario increasingly unlikely. Researchers are now shifting their focus toward the search for technosignatures, evidence of artificial light potentially generated by advanced civilizations. The question is whether the light observed on Proxima B's night side could be artificial in origin. If so, it might come from cities or industrial complexes, which would emit light in a very different way compared to natural sources. For instance, artificial lighting, like that from LEDs, lasers, or other electrical devices, typically produces a non-continuous, non-thermal spectrum, unlike natural emissions. These signatures can be isolated using advanced spectroscopic techniques, exactly what scientists are now pursuing by analyzing the spectral energy distribution in the infrared range. Their goal, to unravel the mystery behind the unusual glow coming from Proxima B. At the heart of this investigation is the MIRI instrument aboard the James Webb Space Telescope. This powerful mid-infrared device is crucial for determining the true source of the light. Capable of detecting wavelengths between 5 and 28 micrometers with high sensitivity, MIRI was specifically engineered to differentiate between thermal and non-thermal emissions. Artificial light, for example, would exhibit a spectral pattern that deviates from the typical Planck curve associated with thermal radiation. MIRI also uses spatial analysis to assess whether the light appears as a sharp point, suggesting a specific source, or as a diffuse glow, which is more consistent with natural emissions. Additionally, researchers are exploring whether the light shows signs of modulation or encoding, another potential clue that could point to an artificial origin. If a signal repeats at a precisely defined frequency, it could suggest a deliberate transmission, possibly a sign of targeted emissions. Similarities to pulse width modulation in modern communication systems raise the possibility of a technological signature from an extraterrestrial source. However, no such signal with clear, intentional modulation has been detected so far, which leaves the hypothesis neither confirmed nor disproven. Currently, there are four leading theories to explain the observed light emissions: atmospheric airglow, volcanic activity at the subsolar point, starlight being reflected or scattered by dust or gas, and artificial illumination. We're eager to discover which explanation holds true. The Extremely Large Telescope, ELT, in Chile is expected to provide definitive answers. With its advanced capabilities, scientists hope to determine whether the emissions are natural in origin, or potentially the first evidence of an alien civilization. So, what do we really know about Proxima B? It's a planet orbiting Proxima Centauri, the closest known star to our Sun. This star, a red dwarf of spectral type M5.5, is much smaller than the Sun and is part of the Alpha Centauri system, located roughly 4.24 light-years away from Earth. The Alpha Centauri system includes three stars: Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. Unlike the tightly bound binary pair A and B, Proxima Centauri is only loosely gravitationally connected and may have been captured by the system at a later time. It's believed that the two larger stars, Alpha Centauri A and B, might have pulled in the much smaller Proxima Centauri. Proxima Centauri has a mass of just 12.3% that of our Sun and emits only 0.17% of the Sun's light, making it nearly impossible to see with the naked eye. Despite its faintness, its close distance to Earth makes the Proxima Centauri system a key focus for exoplanet research. In 2016, scientists discovered the exoplanet Proxima B using the radial velocity method, analyzing data from the HARP spectrograph at ESO's La Silla Observatory in Chile. Proxima B has a minimum estimated mass of 1.27 times that of Earth, classifying it as a terrestrial planet. It orbits extremely close to its star, just 0.0485 astronomical units away, or about 5% of the Earth-Sun distance, with a short orbital period of only 11.2 Earth days. Remarkably, Proxima B lies within the star's habitable zone, the region where liquid water could potentially exist on the surface. However, due to the planet's proximity to its host star and the star's gravitational pull, Proxima B is likely tidally locked, meaning one side always faces the star. This results in stark temperature contrasts between the permanently lit side and the side that remains in darkness. The Proxima Centauri system continues to be a major focus of exploration for numerous observatories and space missions. Alongside the James Webb Space Telescope, instruments such as the espresso spectrograph on the Very Large Telescope, the Hubble Space Telescope, and the upcoming Extremely Large Telescope are all actively involved in the study. These advanced telescopes utilize specialized spectroscopic techniques in both the infrared and visible light spectrums. Using these methods, scientists can more accurately analyze the atmospheres of exoplanets like Proxima B and search for potential biosignatures, clues that may indicate the presence of life. The excitement surrounding Proxima B has even drawn the attention of private investors. One eccentric billionaire and passionate space advocate is funding the ambitious Breakthrough Starshot initiative, which plans to send tiny light sail-powered probes to Proxima B. These miniature spacecraft, traveling at 20% the speed of light, could reach the Proxima Centauri system in just 20 years and potentially return the first images from our stellar neighbor. While this mission is still in the planning stages, Proxima B is already among the most extensively studied exoplanets in the galaxy. There's even theoretical research underway to detect artificial light sources, adding another intriguing dimension to the search for extraterrestrial life. Edwin L. Turner and Avi Loeb have contributed significantly to the study of artificial light, which is defined as light intentionally created rather than occurring naturally. Searching for artificial light on exoplanets is regarded as one of the most promising methods for detecting technosignatures, signs of advanced technological civilizations beyond Earth. Avi Loeb of Harvard University and Edwin L. Turner of Princeton University are leading figures in this research area. Both scientists have published influential papers and helped advance technologies relevant to this field. Their hypothesis is based on the idea that technologically advanced civilizations on exoplanets might use artificial lighting to illuminate cities, industrial complexes, or spaceports, much like humans do on Earth. On our planet, a large portion of nighttime light is man-made.